everybody. We're here at the SPS 2024, and we're actually standing right in front of the BE Services booth. They actually have a pretty exciting product to show. They just launched their eTSN toolkit, which also includes, it's built on top of eFlex, the embedded Flex SDK for OPC UA. So we'll walk over here and talk to Melvin about some of the demo that they set up, and we can talk about the details of what they put in. So, Melvin, hey.
Hello,
good to see
Darek.
you. Melvin is the project manager for the eTSN stack. And actually, Melvin, you guys put together a pretty good looking demo here with, I see some devices and controllers. Maybe walk us through what are we looking at?
Yeah, so today we are showing eTSN SDK's performance with controller to device communication and controller to controller communication, and also they are talking with third-party devices, which shows that we are also interoperable. So this one device sends the data to 4 of these devices that are here, and each of them are controlling the LEDs, and then we are making a LED pattern that will control, that will show that they are all in time synchronization.
Okay, so by the pattern, the way the lights are blinking shows the synchronized sort of back and forth. Okay, all right.
So the one more interesting part is when this particular controller sends the packet, it goes through the switch and then it reaches to each of these devices. And also from this controller, it reaches to these 2 devices. The thing is, the controller, when it sends it, it reaches these devices in a high jitter mode. So the jitter is just plus or minus 4 microseconds, which we can see it in our test suit that we are seeing.
So 4 microsecond jitter, not bad. Now on this screen, I mean, you have various things I'm seeing here. Are you showing the division? This is when you guys are dividing the traffic, the bandwidth.
So the cool thing is, this is like an IIoT convergence kind of a demonstrator. So here you can see that in this video, streaming is also, it's available in the network. But still you can see that the LEDs are not disturbed because we are using 802.1 AS and 802.1 QBB. So with that, you can we can assure that the isochronous traffic is always delivered in the jitter that we are promising, but still you can see that the video streaming happens and there is no problem here.
Okay, so what you're saying then, for those maybe not familiar with it, when we have TSN or running on top of TSN, we have OPC UA. So we're sharing the bandwidth. So basically that's why you're showing the video plus the control, and that's using the
so imagine you have a bandwidth of 10 Gbps, then we are going to say that all the time the traffic that is isochronous will not be disturbed at any point of time, which is hard real-time traffic, and we can allocate the rest of the bandwidth for other traffics like audio, video, voice over IP, configuration data, and things that are non-important. So imagine this is something like your airbag data comes in always, but your music data will take some time. So we don't want people to die. So that is a thing that we are doing. So these are time-critical systems that is being demonstrated here.
And now for this, that's great. So for these guys, obviously this is showing some embedded capabilities. Give us a feeling for how much memory, for example, this
these
takes.
devices are low footprint platforms, so that's the specialty of eTSN, which is embedded TSN, we could say. So these platforms are less than 1 MB of RAM. This TI device is a bit higher, but Renesas is operating at 1 MB of RAM.
So we have, just to see, there's Texas Instruments. So we got, what are you running for Texas Instruments?
So the hardware is AM342X.
All right. So so then we got Renesas and ST Micro.
So the overall consumption of RAM for this SDK is 600 KB. It's less than 600 KB is the target.
And that includes both the eFlex for the embedded OPC UA.
Not only that, we have 802.1 AS PTP, we have LLDP, we have the lightweight IP stack, we have the FreeRTOS, we have OPC publisher, subscriber, and a server running, and on top of it, we have this user application running as well.
Fantastic. So basically, this goes to show you guys that putting OPC UA onto a small footprint and being able to bring let's say the whole library of a fairly complex system for the TSN all together under the eTSN stack, very possible, and obviously you can see it in action. So Melvin, thanks a lot for the overview.
No problem.
And see you around. So guys, that's it for our visit here at the BE Services booth, and see you next time. Thanks.